Hey there. We are going to work on converting degrees into radians. Good? Okay, here's what I did first. I decided to draw my grid system, and I decided to mark at each of the boundary lines at the XY axes the degree and the equivalent radians to each of the degrees. Why? Because when I do that, here's what I'm noticing. I'm noticing that 0 degrees is 0 radians. That doesn't help me. I'm also noticing that 90 degrees is equivalent to pi over 2. Well, that's nice, but that means I have to deal with a fraction here. I'm also noticing that 180 degrees is equivalent to pi. That's not bad. I like that one. 270 degrees is equivalent to 3 pi over 2. Not liking that so much because I got to deal with another fraction. And I'm noticing that 360 degrees is equivalent to 2 pi. Now here's the deal. From these equivalent, I get a conversion, shall I say? And conversions are written as fractions. So here's the deal. This first one, I could write 90 degrees is equivalent to pi over 2. Or, if I want the radians on top, I'm not liking that one at all. I don't want to deal with a fraction in a fraction. So I don't like this as a conversion whatsoever. I'm noticing this one, though, 180 degrees is equivalent to pi, or pi over 180 degrees. Either way I look at that particular conversion, that's okay to use. I'm liking this one. This one I'm not even going to bother because I already know what the 90 degrees and the pi over 2 look like, and those are pretty ugly fractions. This one, 360 degrees over 2 pi, or if I wrote the conversion as 2 pi over 360 degrees, those are pretty nice also. But here's what I'm noticing. I'm noticing 360 degrees over 2 pi reduces down to 180 degrees over pi. Might as well use that. Or if I need this conversion, 2 pi over 360 degrees, I'm noticing it reduces to pi over 180 degrees. Might as well use the reduced form. Here are the two conversions that we use. Cool? Okay. Now the question is, which one do I use? Now, here's a technique I learned in high school. Never forgot it because to me, it was super easy because I didn't have to necessarily figure out where the numbers went as I had to figure out where the units went. I was taught always write the original problem as a fraction if it's not a fraction. So put it over 1. Now they want it in radian measurements, which means the degrees must cancel. So since this degree is in the top, I need a degree on the bottom so the degrees cancel. Which means, which of these two conversions would I use? Do I want the 180 degrees on the top or do I want it on the bottom? Yeah, you want the 180 degrees in the denominator, which means the pi goes in the numerator, which means the degrees cancel, and you're left with 15 pi over 180. No degrees, the degrees cancel because you had one in the numerator and one in the denominator. Good? And yes, now you have to reduce that, which means you'll get pi over 12. Cool? Okay. These are the two conversions I use. And depending on what I want to get rid of, tells me what goes on the bottom. Since I want to convert to radians, degrees have to go, which means 180 degrees need to go on the bottom. Cool? Okay, I've got some examples coming your way, but first, work on them before you go find my answer key video. Good? Catch you on the flip side.